Welcome to the ET380 lecture video on operational amplifiers. An operational amplifier, or op-amp, has two inputs, an inverting input and a non-inverting input, and typically has voltage plus and minus power sources. Real world versus ideal op-amps. An ideal has infinite loop gain voltage. A real one is around 100,000. Input impedance isn't infinite, or a real one's about 2 megohms. Output impedance is 0, real world's about 75. Input offset voltage is 0. And we say that it has an infinite bandwidth, infinite common mode rejection, and infinite slew rate. But those are with some reasonable numbers. Internally in an op-amp, we have a differential voltage input stage, voltage amplifier stage, and a push-pull amplifier stage for current. Operational amplifiers have very large gain, what we say infinite gain, and if we put a very small signal in, like 1 millivolt into the non-inverting input, it is going to go to the maximum level, and that level would be limited by the power supply. So if we put it into the non-inverting, it's going to go to the positive power supply. If we put a minus voltage into the non-inverting, it's going to go to the maximum minus voltage. Common mode input, we call this common mode rejection, that when we put in signals because of the inverting mode, that we're going to take two signals, and one's going to be positive, one's going to be minus, and they're going to cancel each other out, so noise on an op-amp will be eliminated or reduced. Because of the infinite gain, op-amps typically are useless until we do some difference with a negative feedback network. With a negative feedback network, we could control the gain to what we want and make them useful amplifiers. Here we have an inverting operational amplifier where we take our signal and we put it into the inverting, and then we have a feedback network, which is a voltage divider, and that limits our gain, and we could control it. So our voltage gain would be the feedback resistor divided by the input resistor, and that would give us the gain. Here I show an inverting amplifier with real resistors. So if we have 100K feedback and a 10K ohm input resistor, so our gain would be 100 divided by 10K, and we'd have a gain of 10. So if we have a voltage input of 100 millivolts times 10 is going to be 1 volt. Non-inverting operational amplifier will take its input signal and put it into the non-inverting input, and its formula is the feedback divided by the input resistor plus 1. Here's an example with the same size resistors, and our gain is going to be 11. 100K divided by 10K plus 1 is going to 11. So we have 100 millivolts in. 11 times 100 millivolts is going to give us 1.1 volt. Okay, op-amps have something called virtual ground. We're at this point where we have the input and the feedback resistor connection. Whatever voltage we have on one input is going to be the same as the other one. Being that they're the same, we're going to say 0 volts, so we're going to say that's virtual ground. So if we were to take a measurement at that point, we would read 0.